could make through. So yesterday what we did, so we discussed about recursive, then so we also discussed about memorization and tabulation, right? Okay, so this is a purely DP. So even in best case, which is taking n square, and other case which is taking 2 power n. We thought it is 2 power n square, right? Ideally, it is not 2 power n square, which is 2 power n. Why? Because, for example, let's say let's say in reverse thinking, you are reaching I4. If you want to reach I4, you can reach either you can reach from 0 or 1 or 2 or 3. So these are the index numbers. 0 is already reached. If you want to reach 1, you can only reach from 0 because from previous index only you can reach to the last index. For 2, either you can reach from 0 or you can reach from 1. And for 3, you can reach from 0 or 1 or 2. So this is how it is. In worst case, the length of a branching, right, which is equivalent to n. So which is equivalent to n. So that's why it's 2 power n. Even if you go little deep, then there are some math principles. It is tough to understand, but if you think in a worst combination, so which is n. Okay, so let's move on. Let's understand. Let's see the problem statement. You have 3, 2, 3, 1, 1, 4, right? Are you clear on tabulation, memoization, and recursive solution? The one we discussed other time.
Yes. Yes, Shreya.
Yeah, nice.
But on the time complexity only little bit.
Is it
Yes.
which is not clear? Recursive time complexity is not clear, or others are not clear?
2 power n.
Okay, you can spend some time on it, even if I
Yes, yes, true.
explain
Yeah,
doesn't
got
work.
it.
Okay, uh, fine. So we were talked about tabulation, right? So let's understand there is a greedy approach. There is a greedy approach for it. Uh, if you closely see, right, let's go to the how do you come up to the greedy solution, right? It's not something you get it blindly. If you closely see, there were this was the tabulation code. So this was the tabulation code, isn't it? Okay. Oh, this is I'm going to. Yeah. So if you closely see, this was our tabulation code. Uh, let's understand what is the mistake we are trying to do. Then, then we will see. So what are we trying to do? So first we are okay. Let's not compare with this. You can try to convert that. This is our greedy sol. We can come up with the greedy solution because the tabulation code which we have written, yeah, we can derive it from through, but you may get confused. But let me talk about as a greedy solution so that it will be simple to understand. So you have four indexes 0, 1, 2, 3, 4, and this is our last index. Our goal is our goal is to reach the last index. So that is our goal. So let's say I am at last index. So I'm at last index. It means when you are at last index, you are already reached the last index. Then what is your second thought? It means you are already reached index 4. Okay, you are already reached index 4. Now, can you think, can you see, can you say, can you able to reach from previous index to last index? Okay, it means can I able to reach index 3? Can I able to reach index from index 3? Can I able to reach index 4? Yes, I can reach index 4. So that what is your thought? If you are able to reach index 3, definitely you can able to reach index 4 because from index 3 you already solved that sub problem. So from index 3 you are able to reach index 4. Similarly, let's see, can you able to reach index 3? Okay, let's check that. So from index 2, can I able to reach index 2? Yes, I definitely reach index 2 because the value is 1, right? You can definitely reach index 2. So it obviously, if I am able to reach index 2, I can able to reach index 3 for sure. Now let's see the possibility. Can I able to reach index 2 from index 1? Okay, can I able to reach index 2 from index 1? Yes, I can able to reach. So that it means if you are able to reach index 1, definitely you are able to reach index 4. That's how you try to solve it. Now from index 0, can you able to reach index 1? Yes, I can able to reach index 1. So that if you are able to reach index 1, so done, you are able to reach index n so that you can return true. You get it? So it means if you see this is my last reachable index. Initially my last reachable index is 4. Now from index 4 you are able to reach 4. That is for sure. Now let's check from index 3 can you able to reach index 4? Yes, I can reach index 4. So that if I able to reach my index 3 then I can able to reach index 4 so that my current reachable index, my current target is 3. My current target is 3. Now let's check from index 2. Can you able to reach index 3? Yes, I can reach index 3. So this is going to be my current target. So this is my last reachable index. It means our current target. It means if I able to reach index 2, I can able to reach index 4. Now again check from index 1. Can you able to reach index 2? Yes, I can able to reach index 2. So that index 1 is going to be my target. It means if I am able to reach index 1, I can reach index 4. Then from index 0, can you able to reach index 1? Yes, I can reach. So that definitely you can consider this last reachable index as 0. Finally, when do you return 0? When do you return true? So this last reachable index or last target, the target index is 0, then it is target index is 0 or last equals 0, then it is true, otherwise it is false because it means you are able to reach zeroth index from n minus 1 means from 0 to n minus 1 you are able to reach. That's why you can return 0. Do you understand the algorithm, Ajay Kalyan?
Yes, Ram.
So it's a simple greedy technique. We are actually we are applying DP problem only, but there we, whatever tabulation logic we discussed earlier, it's a optimization for the tabulation. We are not able to look it for all possibilities. So for each index, we are not able to reach, we are not able to see for all the possibilities. So that's how it is. You can check on the tabulation solution in order to save the time. I'm not revisiting it. Then you can think about it. Then you will understand what is the improvement we did. So for example, if you have 2, 1, okay, so let me take other input 3, 2, 1, 0, and 4. So if you closely see, I am here. So this is my target. Okay, so let's say my target index is initially 4 because so my target index is 4. So if you closely see, my target is 4. Now from fourth index I can reach 4 so that there is no issue. Can you check? Can you check from here? From third index, can you able to reach index 4, target 4? So no, you can't able to reach target 4. But obviously there is no update. Still you must and should reach target 4. Now again you see from index, then you move back. So from index 1 you can only reach index 3. You can't reach index 4. But our target is 4, right? Our target is 4 as you can't able to reach. So still even if you reach index 2 you can't reach index 4. So there is no change in my target. Now I'll move here. So if you closely see from index 2 at max I can reach index, okay, so from index 1 let's move on. So from index 1, at max I can able to reach index 3, right? Index 3 because the step count is 3. So that you are not able to reach target. So the target becomes still 4. Similarly from index 4 also at max you can reach index 3. So that still the target becomes 4. As the target index is not equal to 0, so it obviously returns false. So for example, if the input is something 33104, if it is something like this, Then what will happen? So you have target which is 4, target index as 4. So from 4 you can able to reach 4. So this 0, 1, 2, 3, 4. So you can able to reach 4. From 3 you can't reach 4, so that there is no update in the target. It means if you reach index 3, you can't reach index 4. So that's what I'm saying. So now let's move on. From index 2 also you can only reach index 3, you can't reach index 4. So that obviously the target index is, it means what is our target index? So our target index is 4. From index 2, can you reach target index? No, you can't reach. So that there is no update on target index. Now can you see from index 1, can you reach target index? Yes, definitely, because current current index plus the value present in that is greater than or equal to my target index. So my target index, so that I can able to reach target index, so that if I reach index 1, so that I can reach index 4, so to update the target index to current index which is 1. So now from index 0 can you able to reach target index, that is 1. So it means 0 plus 3 which is greater than or equal to my target, so which is 1. So that obviously as we able to reach, you can update this target to current index which is 0. So whenever target index is 0, you can return true, otherwise return false. So it's a simple greedy problem, but this thought you can't get unless you put lot of effort on the tabulation solution. So if you closely see, now let's see what is the mistake we are doing in tabulation. So if you closely see, irrespective of, we are trying to see all possibilities from the current index. So this is a mistake we are trying to do on tabulation approach. That is for that the improvised approach is greedy solution. Understood, buddy? Ajay Kalya.
Yes.
So we don't need to do all possibilities, right? So that's why that is becoming n square. Now we will try to solve it to target index. So initially, which is going to be nums dot length minus 1. So now what is our job? So I'll try to start from nums dot length minus 2. So you can directly start from minus 2, because from minus 1 you always reach, yes, right, n minus 1 you can always reach n minus 1 index, so that you can directly start from n minus 2, then index minus. Now from the current index, okay, so from the current index, it means from the current index you can take it jumps if it is greater than or equal to my target index. It means from the current index, if you reach the target index, now for the next index, for the next previous index, the target index is going to be current index. That's it. So finally, your job is target index which is equal to 0. So it's a simple greedy solution. Why you killed 1 hour time yesterday, Srinu? You could have tell this. It could have been 5 minutes task, right? Eh? But getting into this thought is impractical, man. If you put a lot of effort on the tabulation approach, then you can get into this thought. Okay, so it's a greedy solution. So what is the time complexity here?
3M.
Linear, right? So it's a linear. Actually, I could have come from the tabulation solution only, but the problem is you are little confused on it yesterday. So if I start from tabulation solution, then you feel this is difficult. So that's why I skipped it. Okay. Now let's move on to next one. Jump game 2. You see how many problems we have on dynamic programming. There are a lot of problems. We need to speed up, otherwise it will take a lot of time. Okay. So let's move on. Uh, this is jump game too. So what he's trying to say is same as the previous statement. So you will be having indexes. In each index, you will have a number of gems it can take at max. So we need to return minimum number of gems to reach n minus 1 index. So we need to return minimum number of gems to reach n minus 1 index. And if you closely see, uh, it is guaranteed that you always reach n minus 1 index. So the problem statement says there is no negative state case. If you start from 0, you always reach n minus 1 index, but only the constraint is we need to return minimum number of possible gems. For example, let's take the same input. Okay, so let's take the same input. So what is it? So it is 2, 3, 1, 1, 4, right? So you have 0, 1, 2, 3, 4. Now let's see the possibilities. So one possibility should be, let me take all possibilities. So let's take all possibilities. Possibility one is, so I'll take one step, then one step, then one step, then one jump. So this is going to return 4. Okay. So let's see other possibility. I'll take two jumps, then I can take one jump, then one jump. So which is going to return three jumps to reach n minus 1 index. So then then other possibility is I'll take only one jump. From here one jump and one jump. So I think this is already covered, right? So let me take other case. Yeah, so I can take one jump. From here, I can take two jump, then one jump, so which is going to be returning 3. Then I can take one jump. From here, I can take three jumps, so that this is going to return 2. So the out of all possible solutions, right, the minimal jump is 2, so that expected output is 2. So, and the problem statement says that from 0th index, you always reach n minus 1 index. So return minimum possible gems. Okay, so minimum possible gems. Understood, buddy? Understood the problem statement?
Yes.
Now, let's see how do you solve it, right? Let's see how do you solve it. Again, we don't know any greedy and everything. So let's see, let's apply DP, then we will get into the greedy approach. So first thing is, for example, you don't know anything, buddy. So you don't know anything. Assume that you have 0, 1, 2, 3, 4. You don't know any value. Let's forget about it. So I am at index 4. How do you reach index 4? How do you reach index 4? Assume you don't know any values, but what are the possibilities to reach index 4?
You can come from any other indexes.
Remaining indexes, right? It means I can come from
Yes.
index 0, or I can come from index 1, or I can come from index 2 or index 3. So it means if you are able to reach from index 0, it means you are done, right? You are done, right? Yes or nobody? Because if you are already at index 0, if you are already at index 0, it means you reached index 0. So if you are able to reach from index 0, you are done. So which is taking only one jump. So let's go further. Okay, if I am not able to reach from index 0, if I am not able to reach from index 0, then what is my job? I need to look for other solution. Okay, I need to look for other solution. Okay, let me go to index 1. Let me go to index 1. So how can I reach index 1, buddy? How can I reach index 1?
from index 0.
from index 0, right? It means if you are able to reach index 0, if you're from index 0, if you're able to reach index 1, and from index 1, if you're able to reach index 4, then definitely which is going to be two gems, right? Yes or no? Do you get this?
Ye-
Okay.
Yes.
Now, let's say this is also not possible. Let's say this is also not possible. Then what is your job next? You look for other possibility. How do you reach index 2?
Either 0 or 1. One.
So
Yeah.
either 0 or 1, right? Obviously, this is one possibility. So one possibility is from index 0 if you reach index 2, and from index 2 if you reach index 4. So this is giving jump count as 2. And one more possibility is as you don't know, how do you reach index 1? So it is from index 0. It means from index 0 if you reach index 1, from here if you reach index 2, from here if you reach index 3. So the possible jump count will be what? 3. So this is 1, 2, 3. Now, even this is also not possible. So let's go further. Let's go further. So this is also index 1. You can reach 0, 1, and 2. Let me move a little further. Okay, so you have 0, and you have 1, and you have 2. And this is also index 0, and this is 0 and 1, and same repeats. Okay, let's assume this is the worst possibility. Then you will have this direction, and this direction will give you value as 4. Can you tell me, if you understand this flow, can you tell me what is the possibility of this direction? It means number of gems. How many number of gems you have? One, two, three, four. Can you tell me what is the input I should keep here?
All values 1, 1.
That's it, right? So all are ones, right? If all are ones, so what will happen? All are ones. For example, all are ones. Let's say all are ones. So what will happen? uh, you can't reach from index 0. You can't also reach from index 1. Means the target index is 4, right? The target is 4, but can you reach from index 1? Because even if you take one gem from index 1, you can't reach. You can't reach from index 2. So this subtrees don't execute. Then it will move on to the index 3. Okay, so from index 3, can I reach? Yes, I can reach from index 3. Okay, because I can reach from index 3. Now my target is index 3, right? Can you reach from index 0? No, you can't reach. Can you reach from index 1? No, you can't. Uh, yes, because from index 1, if you take one gem, you can't reach. So can you reach from index 2? Yes, I can reach from index 2. Okay, nice. Now let's move further. Index 2 can be reached from 0 and 2. Can you reach from 0? No, you can't reach, so that it won't be possible. Then we will see this possibility. Can you reach from index 1? Yes. And from index 1, can you reach from index 0? Yes. So then the number of gems is going to be 1, 2, 3, and 4. Right? Understood, right? Understood, nobody?
Yes.
What if
Yes.
I have value, what if I have value 3 here? How is my recursion tree becomes, buddy? So if I have value 3 here.
From index 1, it can directly jump to directly index 4.
Yes. So obviously, if it is value 3, so that from index 1, it can directly jump to index 4, right? So that you will see the possibility to index 1. So this is 1 and this is 1. That's it. So you will get 2. You don't need to explore other trees. Yes or no? Do you need to explore other trees, buddy? This is
No.
critical part. So you don't need to explore other trees, right? So there is no point of exploring other subtrees. So that's the catch. That's the catch. So what is the time complexity now? So what's the time
I
complexity now?
think the worst case is the last scenario. Like, yeah, that's the one order of n, the worst scenario.
Yes, so that is order of n. So even this is how it is happening. So first you will 4 and you will see for 0, then you will see for 1. You are not exploring 1, correct? You are not exploring 1, right? Are you exploring 1 possibilities? No, right? Yes or nobody?
Yes.
Where is this guy? Yeah. So you are looking for 0 and it is not possible because from 0 index you can't reach 4 and you look for 1 and 1 is also not possible. From 1 you can't reach so that you don't need to explore this possibility so that obviously this is also gone. Then 2, so from 2 is it possible? No, it's not possible. So that you are not exploring these possibilities. I have written the diagram, but we are not exploring these possibilities. If you are exploring these possibilities, it is different case. Okay, then we move on to 1. So from 1 you move here and so from 1 sorry, we move on to 3. Okay, so from 3 can you reach? Yes, you are able to reach so that you are exploring these possibilities. So from 0 you can't possible, from 0 it's not possible, from 1 it's not possible, so that you are not exploring the possibilities of 1. But yeah, so from 2 it is possible and from 1 it is possible. And do you think it is n or n square? The
N
time,
square.
why it is n square?
Because for the last one, it can be n, but we are still exploring odd when I equal to 0, I
That's
equal to 1, I
correct.
equal to 2.
Correct. So
So
if you closely
it's n
see
square.
for the last one, for I4, what we did, I went into I. It means you get into I3 by exploring other possibilities, right? 0, 1, 2 are not possible, so you get into I3. Now from I3, you went into I2 by exploring 0, comma 1. So as it is not possible, you went into I2. Then from I2, you are into I to the power 0. You are exploring this, but you are directly getting into I1. Then from I1, you are getting into I0. So it means if you see, this is n minus 1, and this is n minus 1, and this is n minus 2, this is n minus 3, and this is n minus 4. So it is n of n plus 1 by 2, so which is going to be n square. Do you see any duplicate subproblems here? Do you see any duplicate subproblems here?
Yes.
Where, man?
If you look at the I2 branch, they were solving 0, 1,
But we are not
and 0.
exploring. Okay, we are looking at I2 branch. With respect to which index? This is where
With
the state
respect.
is. This is where the state is more important, right? State is more important. You are solving I2 branch here and here, but if you closely see, here my I2 branch target is 4, but here my I2 branch target is 3.
Correct. Yeah. The state
So
is different.
state is different. So there are two states, right? So one is target, another one is current, right? So here the target is 4, current is 2, but here the target is 3, current is 2. So that's how you do uniqueness of the problem statement. Okay, everyone get it? I think the one who joined late it would be little tough to understand. What is the space complexity? Kalyan, did you understand?
Yes.
So there are no duplicate problems, right? For sure.
Yes.
It's a
I mean, the
straightforward
ones we are
memorization.
handling only the unique ones. The remaining ones we are not seeing. That's why it is not a duplicate, right?
Forget about exploration of the problem. That is
Oh,
exploration, right? It's not 2 power n, it is n square. Why? Because we are not exploring down the line if it is not possible. That's why it was not 2 power n, it is n square. Okay. Now let's
oh,
look at the duplication of problems. Duplication of the problems can be identified by the state, right? So in this case, the state is target index and current index. From the current index, can you reach the target index? That is what the state, right? So here
yes.
the state is different. So here the current index is 2, target index is 4. But here the current index is 3, target index is 4. Here the current
Okay.
index is 2, target index is 3, but here 2, 4, here it is 2, 3. So there are no duplicates of problem, so that it is n square.
Okay.
Okay,
Got
it's
it.
not 2 power n. Okay. Now,
Yes.
what is the space complexity here?
TCN order of n, because we're exploring only that side
Yes.
at a
So
one
obviously,
set at a time.
obviously, yeah. So at any point in time, the this stack frame gets active, right? Now, what you do is, yesterday we discussed about jump game, right? Try to solve in this direction. Try to solve we discussed in forward direction, but try to solve in this direction. You feel much comfortable. Okay. Okay. So let me write a recursive code for it. How does it work? So definitely, what now? Tell me what my recursive method requires. What's my recursive? So I will try to you can write a pure recursive logic, but I will try to deal with backtracking kind of code. So just take a look. So you will get it. So jump. So I will take the my current index. So this is my target index. Okay. So this is my target index. So what I will do. So for each target index, what I am trying to do. So I will start from index 0. So this is what we are doing, right? In the recursion tree also we are doing same thing. If you closely see, we are simply starting from 0 and moving on to the less than to the target index, right? So for 4 we are starting 0, 1, 2, 3. For 3 we are starting 0, 1, 2. So what you do, this is my start. It means this is my current, which is less than my target index. Then start plus plus. So whenever I am able, when I'm doing it, so when I do it, so whenever, so there is I'm getting into the deep. If you closely see, this is what happening, right? I'm getting into the subtrees even, sorry. So I gets into the subtree only when my current index, from current index, if I able to reach the target index, then only I can able to get into the subtree. Remaining things I'm not going deep if it is not possible. So that's condition I am keeping here. Otherwise it will go to 2 power n. We will try the 2 power n possibility. So if from current index, right, it means from current start, or let me take it as current index. So from current index, it means current index plus nums of current index. From current index, if you are able to reach the target index, if you are able to reach the target index, then you are taking one jump and see, can you reach the current index or not? Yes, that's it. So jump of nums comma current index. Is it clear, buddy? Is it clear? Or return integer dot max value. Is it clear? The diagram and the code
The
is clear.
algorithm was, the diagram was clear, but the code is not super intuitive.
No, no, it's a backtracking code. I have written in a backtracking direction. So it should be for,
Okay.
right? It should be for. Uh, so let me run it so that you will get confidence and we will walk through this code. It's a backtracking code. So you already, so our target index is what, last one, right? So nums dot length minus one. Mm, what's happening? Nums dot length minus one, target index. If it is 0, target index, perfect, current index. Why it is giving all our max values? Let's check that. You want to reach last index, okay. Mm, yes. 0 you can't reach. So you go to 1, 2. Why it is not working?
So, I think the 11th number condition what we have, that is just exploring the when the current index is only zero option. It is not going the other possibilities.
Why? It should be this way, right? So let me. So what is our thought now? So if you closely see, yeah, let's debug it. So what we tried. So let's say this is our possibility. So 1 1 1. So we start from index 4. Okay. We start from index 4. So 0 plus nums of 0 is 1. So 1 is not greater than or equal to 4. So that we ignored it. Then we get into 1. Let me see. So first, okay. So first we start from 4. Now, then we try to start from 0, 0 less than 4, correct? So 0 plus value 1, which is not greater than or equal to 4, so that we don't explore. Then we went into 1, so 1 plus 1, which is also not greater than, so we don't explore. Then 2 plus 1, so which is also not greater than or equal to 4, so we don't explore. Then we get into 3, so now 3 plus 1, which is greater than or equal to 4, now we explored 3. Okay, so for 3 also we did the same. We again start from 0, 1, 2. It should work, but there is a mistake. Do you understand what I try to do? The code? First, let me fix this so that is it because of this or what? Mm, mm, mm. Hmm. Tell me where is the mistake went on, man? Oh, okay. That's correct only. I was overexcited. Uh, uh, uh. 1 plus jump off. I am passing current index only. Let me print this. Does it get into here or not? Why it's not going further? Yeah, it was printing, right? If you closely see, it was printing the value. So it means you got count as 2, but it is returning max value. If you closely see, our logic is working, man. This is our logic is working, but somehow we are getting the max value. So this is the tricky part. Hmm. If I ignore it, definitely it will fail. It will give compile time. Do you understand our logic is working or not? If we closely see here, th this is right. So this one, if you closely see, so first from 0 you will reach index 1, and from index 1 you will reach index 4. because this is possible. So there are only two steps. So you are able to get two times here, so that it is going to be 2. Uh, but why it is getting into here is the question. Once this is done, it should not execute other case. First, did you understand the code? Okay, let me explain the code so that at least you can help me to fix that bug. So what are we trying to do? What are we trying to do? This is the recursion tree we followed, right? So this is a recursion tree we followed. So what we did, so first we see we get into I4. From I4 there are possibilities. I can choose I0 or I1 or I2 or I3. So when I explore I0, from I0 if I reach I4, then it is done. So if I am not able to reach I from I0, if I am not able to reach I4, then I can't go further. Then I'll see, can I able to reach I1 from I4? Because in our case, what it is, 1, 1, 1, 1. Okay, so let's take this one so that it will be easy to understand. All are ones. So 0, 1, 2, 3, 4. So from I0, can I get into I4? It's not possible because 0 plus 1, e- 0 plus 1 is less than 4. It's not possible. From I1, I can able to reach I4. Oh, it's not possible. Now, so that you don't explore, you don't need to explore. From I2, from I2, can you reach I4? Because I2 is index 2 plus the value present at index 2 is 1. So that 2 plus 1, which is not greater than or equal to 4, so that from I2 you can't explore, so that you will look into I3. So can I3, can I explore, can I reach I4? So 3 plus 1, so which is greater than or equal to 4, so that you can explore, so that you will see other possibilities. Okay, I0, I1 and I2. So now again you see from I0, can you reach index 3? It's not possible. So that 0 plus 1, it's not possible, and 1 plus 1, which is not possible, 2 plus 1, which is possible, so that you will explore this one. So I0 and I1. I0 means 0 plus 1, it's not possible, so that 1 plus 1, it's possible, so that you will get into I0. So once you get into I0, definitely this is from 0 you can reach. So 1, 2, 3, 4. So if you closely see, did you understand? This is what we did through code, right? Yes or nobody?
Yes.
So the target index is initially, which is 3, means length minus 1, which is 4. Starting from 0 to 4, we seen all possibilities. Whenever it is becoming 3, current index becoming 3, so 3 plus 1, which is greater than or equal to 4, so that it is getting into that, then it is exploring 3. So if I take test case as all ones, then at least you can see this output. So 0, 1, 2, 3, 4. So there is a mistake we are doing while returning the value, so that we need to fix. So if you closely see, it is in 0, 1, 2, 3. It is able to return that value. So this is the mistake we are doing. It is always returning max value. Why? Why? Because
You're not taking the minimum one, right? You're returning in the line number 13, but you're returning integer dot max value.
no, I that there is one possibility. As per your suggestion, I can try that. One possibility is this one, buddy. Integer I can take min equal to integer dot max value. Then so you will get the current jump. This is one possibility, but I'm actually this should not be the case. This is min jump. You can consider min jump comma current jump, and just what is it?
And
Go for min jump. So this
Some
is
other possibilities, when the target index is coming to 0, that time also we need to return it, right?
why it is going. Just a minute, bro. Even this case also
Sure.
it's not working. Even this case also it's not working. It's not the problem with
I
it's not
think
the
that is nums of index. No, jump of nums comma current index.
yeah, that's what we are doing, right? So once we are current index is possible, we are exploring the current index.
Okay, that current index. Yeah,
Yeah.
if that is, yeah, okay.
Why it is getting into understood, man. So tell me where the problem went wrong.
Uh, we are not checking the min jump is greater than or equal to integer at max value.
No, no. The problem, no. With respect to this code, can you tell me where the issue went in? So there is no point in taking min even if you don't take it also it should work. Where you get max value, tell me.
When the current index is 0.
Right, so when the current index is 0, so 0 less than 0, target also 0. When the current is 0, target also 0, then obviously it will return max value, so that we need to fix that.
So when the
So
current index is 0, sorry, when the target index is 0, we need to return 0.
then it will always return 0.
I think earlier code it works with min jump.
No, 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 it didn't work, right? We tried it.
If you check with the integer at max value whether the min jump is greater than or equal to,
No, no, it didn't work, right? Same logic, na? How, even if you see, this is what we did, right? Same logic, right? It doesn't, it will again return this min jump and it will return min max value. So again, it will the same issue. Interestingly, I have solved this problem before the session. That's why I don't want to see that solution. Before the session, I have written some code and it worked. Then I have had an argument with ChatGPT regarding time complexity. I don't want to see that. Uh, why it is failing? Let's explore that.
Signal, why are we returning integer max value?
What can we return?
0.
If we return whatever value you return, so it will just return that. It will just give that, right?
Yeah, it's adding to our result, but we do not want that to happen, right? So 0 should be written.
Okay, if I return yeah, 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 yeah. What a catch. Great catch. Did you understand, man? That's a great catch, man. So what is happening when you return integer dot max value, right? Integer dot max value. So what is happening? This max value is adding to the result, right? Yes or no? This has been adding to the result or not? What is happening, bro? Let's see this. How our logic is working here. Yeah, that's a great catch. Okay, so let's see here. So what is happening here? So initially, let's look at the possibility. So we have I4, right? From I4, I tried for 1 plus I3. From I3, I tried for, okay, not. So this is what happening, right? So this is a, so you have I4. From I4, we are going with 1 plus I3, right? From I3, we are going with 1 plus I2. From I2, we are going with 1 plus I1. From I1, we are going with 1 plus I0. So, if you closely see, from I0, it means if the 0 less than 0, so it is true, 0 less than 0, so this will fail. So, obviously, it won't get into for loop. Then it will add integer dot max. It will return integer dot max value. So, if it is returning max value, then 1 plus max value, 1 plus max value. So, that's how it gets into the. output issue. Understood? Others also understood, Akash. So, so when you are at zero, you must return zero. So if you return max value, then definitely this will screw up. So it's a problem with this return value. Yeah, thanks, Maithili. I think semicolon missing. So it should work. Okay, so we have 15 minutes time, right? So let's. Can you convert this into tabulation? How do you convert this into tabulation? So this there is no duplicate subproblem, so that you don't need to have memoization. Uh, I'll 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 give a choice of. So what are we doing here? How are you able to get optimistic solution here without applying anything? How are you able to get optimistic solution here? How are you getting optimistic solution without applying any common sense, right? So can you think about it? Then we can at least come up with the iterative approach. So what is happening here? So we have I4, right? For I4, let's say everything is 1, 1, 1, 1, 1, 1. So 0, 1, 2, 3, 4. So it is I0, I1, I2, and I3. And we are not exploring this because you are not able to reach. Then you get into 1 plus I2. Then you get into 1 plus I1. I'm not exploring I0 because you are not able to reach. Then you are getting into 1 plus I0. That's it. So this will return 0. So this will return 1. So that 1 plus 1 becomes 2. This will return 2. 1 plus 2 becomes 3. So this is going to be 1 plus I3, right? So this will return 3. So 1 plus 3, which is equal to 4. So that you are able to reach in 4 steps. So that's the expected output. Now, what is the optimization we are doing? Tell me. So you're not applying any brute force. It's a perfect valid solution. So what is the optimization we are doing? And what is a mistake also? What is a mistake we are doing? So it's a
To
pure
optimize it, we can begin from n minus 1 side instead of starting from beginning.
n minus 1 side. So what if I value 4 here? 4, 1, 1, 1, 1.
Right. Yeah, ideally it should start from the beginning only
So
so
it
that
doesn't
we can
matter, right?
convert the
So it
neutrons.
will again leads
Yeah,
to the n square only.
correct.
So the mistake we are doing is, the mistake we are doing is, uh, we are trying to we are trying to reinforce all possibilities. Okay, I0, I1. So we are trying to repeat these possibilities. We are trying to repeat all enforcing possibilities. If you see I4, we are repeating 0, 1, 2. I3 also we are repeating 0, 1. I2 also we are repeating 0, and that's how it is. So we are trying to repeat all the possibilities. So we want to avoid that. We want to avoid that. So let's see how can you avoid it. That's where the technique of greedy comes here. So let me take the input as 3. Okay, so let me take 2, 3, 1. Somewhat good input, man. I think he has given 23014. Okay, this is also doesn't help. Okay, that's okay. So 23014.
Shouldn't we are not seeing the right, right?
Yeah. So 0, 1, 2, 3, 4. So how do you optimize it, right? So you want to optimize it, and at the same time you don't want to repeat the same occurrence again and again. So let's see how do you do that. So one way is uh, let's say this is my uh, input. Okay, so this is my input. So initially I will start from 0. If I start from 0, so where I can reach at max? where I can reach at max.
Index 2.
So it means if I start from 0, I can reach at max till index 2, right? Because there are two gems. I can reach at max till index 2. It means this window will always cover jump 1 only, right? Yes or nobody? This window will be covered with jump 1, right? Yes or no?
Yes.
So from this window, if I am able to take any jump, it becomes plus 1 only, right? So from 0, I am trying to reach at max index 2, right? It means I can cover this window with one jump. It means I can cover up to two indexes with up to I can cover up to two indexes with one jump. From these two indexes, right? From 0, 1, 2, of course you covered 0. Then from 1 to, if you take any from any index, if you take any jump, so if you are able to reach the max index or n minus 1 index, then it will add only plus 1. So let me go little more detail. So first I cover this jump. For initially what I'll do, uh, I will consider the current window length as first index length. Okay, so this is my window length. Before getting into algorithm, I want to explain the analogy. Uh, So let's move on. If I explain the code, then we will by heart that code. So that's 23014 and 01234, right? Right. So now if you closely see, with jump 1, we covered this index, right? We covered up to index 2. And it means you have with jump 1 you have possibilities of index 1 comma 2. Okay, so index 1 comma 2 possibilities were there with respect to jump 1. From index 1 comma 2, from either of the one index, can you able to reach the last index or not, so which is to be observed. So if you closely see, from index 1 from index 1 if I take from index 1 if I take 3 jump, it is going to reach the last index. Okay, so this is my jump to, correct? This is my jump to. Do you understand? Others, please understood. So it means what I did, I'll take another input for more clarity sake. So what I did, so from index 0, I covered up to index 2. So index 0 is done. Now you want to see from index 1 comma 2, any index can able to reach the last index or not, then that you just need to see that, so that it will add one more jump so that you will get output as 2. So let me take one more input. Instead of 2, 2, 2, 1, 4. Okay. Let me take one more input. So 2, 2, 2, 1, 4. So let's see first the first possible jump from index 0, you can cover up to index 2. Okay, so this is my first possible jump. Okay, so I can take it as jump 1. So as you covered, it means the max reachable index as of now, which is 2. The max reachable index as of now, which is 2. So when you get from any window, whenever you get max reachable index as n minus 1, so you can just return the jump count. Right now the jump count is 1. So you already covered index 0. So let's look for index 1, 2, 3, 4. So you already cover index 0. So let's look for index 1, 2, 3, 4. But in this case, if you want to target only index 1 comma 2, and right now my max window index, the max window I can reach is 2. Now let's move further. So you have 2, 2, 2, 1, 4, and this is 0. Okay, this is 0. So this is my current window length, right? This is my current window length. So within this, from this window length, can I able to reach? Okay, so let's see if I start from index 1, obviously you start from index 1. So from index 1, I can take plus 2 jumps, so that if from index 1, I can only reach this one. So in this case, from index 1, I can reach index 3, so that it means earlier my window size is 2, but now the window size is going to be 3 because which is extending the window, because from index 2 you can jump up to 3, so that my window size becoming 3 now. Now, now let's move further. Let's go further. Okay, so let's do one thing. So you are at index 1 comma 2, right? So this window length is defined by the previous jump. So from the previous jumps you got window length as 1 comma 2. So let's check within this window length can you reach max length or not. So okay, so if I start from 1, then 1 plus 2, which becomes 3. So I can't reach max index, which is 4. Then if I start from index 2, 2 plus 2, so which is going to be 4, I am able to reach max index. So that as I reach max index, as I reach max index, it means what you should do within this window. First, within this window, what is the farthest jump you can make? Find out that farthest jump. So within this window, the farthest jump you can make is 4. So so 4 is equivalent to given nums dot length, so that you can definitely return 2, because within this in window you take farthest jump as 4, within this window you take farthest jump as 1, so that here it is one jump, here it is one jump, so that 1 plus 1, which is equal to. Do you understand? Do you understand, buddy? Did I make it confused? Okay, if things not clear, things not clear, so now you will understand if I simply walk through the code, right? So you can easily understand, but that's not my intention. uh, 0 1 2 3 4, right? So first you are here, so this is your window, because you always start from 0 only, na? So you always start from 0. So first you are here. So when you are here, what is the farthest jump you can make? So from here, what is the farthest jump you can make? If you take one jump, you can reach up to index 2. So the farthest jump you can make is 2. Okay. So you will also take one variable jump, farthest jump. So which is equal to index 2, because from index 0 you can reach here. Now you are having one more window, right? So this is one more window. This is my current window length. Okay, so my current window length. So there are two ways. So this is our window length. Window length initially which is 0. So initially which is 0. 0 means from 0th index you can reach up to 2. So that my window length becomes 2. Now within this window length, so can you able to reach what is the farthest jump you can make? So within this window length, it means from index 1 to index 2, what is the farthest jump you can make? One is you one from 1, if you take 2 you will get 3. From 2, if you take 2 jumps you will get 4. The farthest jump is going to be 4. So the farthest jump is going to be 4, so that you get 4 here. uh, right? So it means from there are two possibilities. Either you can take this one or you can take this one. Either of the way it doesn't matter. What is the farthest jump you can take, which is 4? So you will consider within that window, you will consider only one jump from the window, one jump per window. That's how it works. So for 0 you consider one jump, so that you reached index 2, and then after 0 you will have index 1 comma 2, right? So from this window you consider one jump, so that you reached farthest index as 4. So it obviously 1 plus 1, so which is going to be 2. So do you understand, Maithili, Akash? Okay. uh, okay, so how do you write the logic, right? So how do you write the logic here? There are two cases. One way is if I write the logic, you will get it. So, but how do you write the logic? So, what are the considerations we should consider here? One is window length, right? Because I want to know. Uh, what are we trying to do? So, one is window length. From each window, what is the longest jump you can, farthest jump you can make, right? So, farthest index you can reach. So from each window, what is the max index you can reach? So just calculate that until that max index becomes n minus 1, less than n minus 1. It means if you reach n minus 1, you all already reached. So less than n minus 1, you just consider that. And for each window, just calculate the jump count. Then it works. Simple. Okay, so let me write the code so things will be clearer. So what I'm trying to do, one is window length. This is my window length. So initially, which is 0, and I'm starting from 0th index, and I'll also have farthest index, so which is also initially 0. So you are at 0, right? So when you are at 0, so it is 0 only. So what I will do, I will try to make sure that this farthest index, which is less than my nums dot length minus 1. Less than. Why less than nums dot length? Because if you reach nums dot length minus 1, you already reached. That's why you apply not less than or equal to, it is less than. Okay. So initially the jump count which is 0. So that's the jump count. So what we do, so this is my current window length, right? So let's calculate. So so this is my current start. So my start is less than or equal to window length. Okay, so let's calculate what is the maximum jump you can make from here. Okay, so for each window, so current max index, you can take it as current max index. So which is initially 0. So what you do, current max index equal math dot max of current max index comma from this index nums of index. Do you understand what I'm trying to say? So this is what we did, right? So from this window, what is the maximum index you can reach? So what is the maximum index you can reach? That is what it is talking about, current max index. Okay. Then when do you increment the jump count? So now we need to increment the jump count, right? So when do you increment the jump count? When do you increment the jump count?
As and when if you reach any index from starting index.
So this is a critical observation. So let's say here, uh, yeah, obviously 1 4, right? So as per our logic, so this is how it is, right? So initially the current window length is 0, so that initially it will cover only this. So from this, the max index you can reach is 2, so that current max it becomes 2, current max becomes 2, and the farthest index also, you will just update the current farthest index equal current max index, which is equal to. So you reached jump 1. Now what is going to happen? So if you closely see in the next observation, how does it work? So you will have 2, 2, 2, 2, 1, 4. So already you are done with this. Then your window length, right? So your window length becomes what, buddy? Your window length becomes this one, right? Yes or no? Yes or no? For the next iteration, the window length becomes this one, right? Yes or no, buddy?
Yes.
I think today I am giving lot of confusion. Huh? Okay, so your window length becomes this one. Okay, so 0, 1, 2, 3, 4. Now again, you start from here. So you already get one jump. So if you start from here, you reach here. If you start from here, you reach here. So you will always get current max is going to be 4, because from this window the maximum jump you can make you equal to 4. So the max jump you can make equal 4. And window length also, what is the what is the maximum jump you could make? So that is the window length. So our window length also becomes 4. Get it? So that's it. So even this window also you consider only one jump. This window also you consider only jump. So here one, so which is going to be 2. So what you can do blindly, so my window length is equal to this current max index, obviously, and my farthest index also becomes this current max index. So that's it. So each time you will just increment the jump count and you will just return jump count. Is it clear? Is it clear?
Yes.
There is a mistake of start.
And farthest index less than num_start length, right?
That's what I'm saying, right? Earlier I said, for example, you have only input 0. You have only input 0. Then what is how many number of jumps you require to reach index 0? You are already at index 0,
Ah,
right?
yes.
So you
Yes.
don't need a jump, right? So that's why it is -1, not less than length.
Okay. Yeah, got it.
So that's it. Did you understand, man? What I am trying to say is at each index we are trying to find out uh, maximum index you can reach. You update that max index to window length, and you'll also update that max index to farthest index. The farthest index you reach is less than length -1. Then, so what are we trying to do is from each window we are trying to find out the jump count. So we increment jump count only once for each window. So what is the time complexity here?
N square.
And so can you think about it once?
It's En, right?
To be precisely,
2n.
it is 2n, right? Why? Because uh, how do you? It is
Because
not
in the
even.
current window we are seeing each index 2 times maybe.
No, it is not even 2n, right? It is n only. When do you revisit 2 times?
Okay, even in current window also, okay, we'll take each index at only
This
one time.
start, right? This start from starting from 0, it is reaching up to n.
Okay.
Clear, Ajay? It's not n square, right? So where do you see n square?
I feel like when we're starting from zero index,
Uh,
we still keep traversing to next possible options.
yeah.
Let's say if we have a value, the array has value
Where
1, 1, 1.
start can reach at max? How many times each index will be visited here?
In this case, I think only once. Yeah,
Mm.
each index is only once.
Even in other case also, can you think?
Yeah, even though if value have 1, 1, 1, then also we are touching each index only once,
Yeah. So the
not
only
twice.
catch is this sliding window, right? So we wanted to handle through window length. So I made this logic somewhat more. You can make it short. Uh, you can put some time on it. It's a greedy algorithm, na? Uh, if you get into the code and understand the data structure, let me stop it.